You have to know what is footing. Actually, footing is a type of foundation. Now, what is foundation? Foundation is the part of structure below plinth level up to the soil. It is in direct contact of soil and transmits load of superstructure to soil. Generally, it is below the ground level. If some part of foundation is above ground level, it is also covered with earth filling. This portion of structure is not in contact of air, light, etc. Or to say that it is the hidden part of the structure. Okay, there are few types of foundation. Generally, there are main two types: shallow foundation and deep foundation. There are four types of shallow foundation: individual or isolated footing, which we will going to learn. Next is combined footing, then strip footing, and wrapped or mat foundation. And there are two types of deep foundation: pile foundation and drilled shafts or caissons. Now, in this lecture, I'm going to tell you what is isolated footing and what is the design aspects and design steps of isolated footing and the types of that kind of footing. Okay, so isolated footing is the most common type of foundation used for building construction. This foundation is constructed for a single column and also called a pad of foundation. The shape of individual footing is square or rectangular. So there are two type of isolated footing: square footing or rectangular footing, and is used when loads from the structure is carried by the columns. Size is calculated based on the load on the column and the shape bearing capacity of soil. Let's take a look to the design step for isolated rectangular footing. Okay. So the basic concept of isolated footing is for rectangular, but in many cases, and the footing may be square, but the basic concept which will be used for design, that is for rectangular footing. Okay, so we have to focus on isolated rectangular footing. Let load on column, shape bearing capacity of soil, grade of concrete and steel are given. So in that case, first of all, we have to find design constants, that is XU max by D and RU for given steel and concrete grades. Before go to the step 2, I like to share you the concept of RU. RU is nothing but there is depends on XU max by D, which is dependent upon grade of steel and grade of concrete. Okay, so let's check a table where RU value is calculated from the formula which is given in Annex G. RU is calculated from the formula which is given for limiting moment in Annex G. Okay, so let's check out the table. Okay, look at this table. This table is for design constants for single reinforced rectangular section, but these constants may be used in many designs. So for limited method, for our purpose, mainly we have to focus in first column grade of concrete, that is FCK, second column steel grade, that is FY. Now column number 5 that is xu max by d, and column 7, that is mu, that is equals to k pd square. Okay, so this k and ru is same. Okay, so the formula is ru bd square. So what is ru? Let's check first. Now ru or k is 0.36 xu max by d within bracket 1 minus 0.42 xu max by d bracket closed fck. So this is from Annex G of IS 456 2000. Okay. So this RU or K value depends upon grade of steel and grade of concrete. So let's check some values. Look, for M15 grade of concrete and Fe 415 steel, the value of K or Ru will be 2.07, right? Say for M20 concrete and Fe 415 steel, the value of xu max by d is 0.48 and value of k or ru is 2.76. Here is written after calculation. Okay, if you calculate the value with the formula which I have shown you, or you can find that formula from IS 456 2000 Annex G. If you calculate the values from formula, you will get exactly this value. So this table has been made dependent upon that value, that equation of NXG. Okay, so say suppose for M25 concrete and Fe 500 steel, the value of K or Ru is 3.32. Okay, so if you have the table and if you remember some of values, that will help you for calculation. Okay, or otherwise you can also use direct the formula from Annex G IS 456 2000. In previous all lectures I have used the formula directly from Annex G, but in this case uh, I have used this formula mm, to make you understand the shortcut way. Okay, so let's check for the design steps. Now step number 2, we have to calculate area of footing as follows. Area of footing capital A is equals to WC plus WF by Q0. Now here WC is load on column and WF is self weight of footing plus pedestal if provided. Usually WF is considered as 10% of WC in calculation. Yeah. And Q0 is safe bearing capacity of soil. In question, safe bearing capacity is given, and in practical field, safe bearing capacity for every zone or for every city or every area is predefined. Okay, so you will get before design, and load on column you also got from column design. Okay, so before go to step number 3, I like to draw your attention in right side of this of your screen. Here is a rectangular footing. X is shorter distance and y is longer distance, and at the middle is the base of column. A is shorter dimension and B is longer dimension of the column. Okay, so in step number 3, we have to calculate the size of footing. For square footing, size of footing is very easy. If we denote one side of footing S, then S is equal to root over A, and we have to round off it. in higher value, definitely not in lower value. For rectangular footing, we have to assume one dimension, say x, and calculate the other dimension, say y, as follows. Y is equals to a by x, and round off to the nearest 5 or 10 centimeters maximum. Alternatively, if ratio of width to length of column and footing are assumed to be similar, say A or B, then bending moment is same in both direction. Okay. Number 4, we have to calculate the soil pressure due to factored column load only as follows. PU, that is soil pressure, factored soil pressure, is equals to 1.5 WC by X into Y. That means the area. In case of square footing, that will be A. Okay. Here 1.5 is the factor which is multiplied with this value to make it factored soil pressure. WC is column load, X is shorter dimension of footing, and Y is longer dimension of footing, just like this. Okay. Number 5, after calculation of soil pressure, the depth of footing is calculated by the following 3 criteria, and highest value so calculated is adopted in the design. Okay, so that is the final step. Okay. So there are three criteria. First one is one-way shear criterion. So let's first discuss the one-way shear criterion. The critical section for one-way shear is taken at a distance d, that is effective depth, from the column space, just like this. If it fails for one-way shear, that one-way shear will be done either through long axis or through short axis, longer direction or through shorter direction. We have to check both of them. Okay, and the critical section of where the shear occurs is d, is at a distance d from the outer face of column. Okay, as you see in image. Okay, in both cases for longer direction shear, one-way shear, and shorter direction one-way shear. So if it's situated at a distance d, then this value will be for longer direction is x minus a by 2 minus d, and for shorter direction, as you see, y minus b by 2 minus d. Okay, so y minus